would like to invite Dr. Jason Blackstock, the head of the Department of Science, Technology, Engineering, and Public Policy, to give his speech titled, Government, Universities, and Society Implications of Digital Transformation. Dr. Jason, please take the floor.
The first main point is that for all of the technology transitions that we have seen over the last 20 years, and Samia did a great job talking about some of the implications of those technology trends, you ain't seen nothing yet. The transitions that are coming, that are already en route, are far bigger than we are prepared for. The second point is this significantly transforms the way governments need to operate, and they're not ready yet. We need a new toolkit for governance in the 21st century, and I emphasize governance as opposed to just government, because a lot more than just governmental actors are going to be required to deal with it. Third, universities have a critical role to play. Our honored chair mentioned the fact that we need to be preparing the next generation to think about, thank you very much. I'm also going to walk around a little bit. We need to be thinking about not only the skill sets that the next generation of students need to have in order to engage the new jobs and the new careers, but we need to rethink the role of the university within society as an agora, a place to bring together conversations about what these transitions mean. So those are my three main takeaways. I'm now going to go through them in a little more detail. Now, let me start, let me see if I can get this out. Let me start with the trends in technology. So I'm a physicist by training, and I started my career in Silicon Valley working on quantum computing, molecular scale electronics, some of the foundations of the modern technological revolution. Now, that was a decade ago that I spent the time in Silicon Valley, and in the decade since, we have seen the foundations of a wide range of new technologies underpinning what is now being referred to by places like the World Economic Forum as the fourth industrial revolution. The first industrial revolution was bringing together mechanization, steam power, etc., in order to be able to enhance the ability of human beings to turn material goods, to turn raw materials into material goods. The second industrial revolution was about taking that capability and turning it into generalized production capability, automated production that led into the third, the computer revolution. And we already begin to see some of the implications of that through what Samia talked about. But the fourth industrial revolution is far more significant. It brings together things like machine learning and artificial intelligence. It brings together the Internet of Things and the connectivity with automation capability, such that it can have incredibly transformative impacts on our ability to produce material goods, to have economic productivity, but without human beings involved. Now, why do I emphasize the without human beings involved? For two reasons. One, in terms of the discussion about what does the toolkit of government look like, there are a wide range of technologies that can be harnessed in order to improve the capability of governments to deliver public services, to understand the trajectory of change that is coming their way, and to be able to sense-make about the rapidly changing environment. And I'll talk a little bit about what that toolkit looks like. But secondly, and far more importantly, there is a rapid transition starting to happen to the workforces around the world. There was a McKinsey report released a couple of months ago about the potential for automation to transform existing enterprises and industries around society. And let me just read one really important statement from it. Almost half of the activities that people are paid to do today have the potential to be automated by adapting currently demonstrated technologies. Half of the jobs out there can be replaced by technologies we already have that are demonstrated somewhere. Now, what does that mean? I'm just going to use one critical example of it. The automation of vehicles, the creation of driverless cars, the creation of driverless trucks. I'm going to use just one statistic that is very much worrying North American policymakers at the moment. There are over 4 to 5 million jobs associated with the trucking industry in the US. Tesla just announced that they are working on a driverless truck that they expect to have on the road by 2019 to 2020. Imagine replacing 5 million jobs in the US between 2020 and 2025, trucking jobs, with automated vehicles. All of the truck stops, all of the commercial enterprises that have grown around it are also implicated. What does that mean? I don't have a good answer for that. But what I do know is that these transitions are coming and we are not prepared for them. So I'm not just talking today about the impact of digital technologies on transforming the way government does existing activities that it's currently doing. There's certainly performance enhancement that's possible. There's certainly the opportunity to improve the way in which government functions. But far more importantly, government needs to start thinking about what it needs to do differently in a world where automation replaces as many jobs as it has the potential to. Half of the jobs with existing technologies, and I haven't even started talking about quantum computing and the potential for artificial intelligence linked with quantum computing to be able to, for example, replace lawyers. Now, some of us may think that's a good thing, but there are limitations to what that means in terms of the economic workforce, in terms of what that means for the future of jobs and productivity. So, what does this mean when we start to think about government and the government toolkit in the 21st century? There are certainly skill sets that need to be developed and new capabilities that these automated technologies, that machine learning, artificial intelligence, automation bring to bear within government. I could talk for hours about this as a technologist, but I'm just going to focus on a few. The first is data science for public policy. The capability of machine learning, the capability of the big data revolution that is being brought about by the Internet of Things can transform the way governments are taking in data. Samia talked very eloquently about some of the projects that are designed to help governments develop their capability to do this sort of analysis. However, we need to be preparing a new generation of technical scholars, computer scientists, with an understanding of what these public policy challenges look like, how they bring to bear the data analytic capability and the sensing capability we now have on public challenges. The big data revolution that we often talk about is driven primarily by the data that is available from the private sector. In 1990, 10% of the data around the world was owned by the private sector, 90% of it was government generated. Today, that is reversed. More than 95% of the data is now owned by the private sector. And being able to analyze that data does give insights into market trends, does give insights into consumer behaviors, but if we're talking about addressing sustainable development goals, if we're talking about addressing energy use, if we're talking about addressing literacy and poverty, is what we really need private sector market data? There's a whole range of conversations that need to emerge and evolve around the types of data that governments and society and the public sector can begin to collect in order to begin to address these types of issues. The second one, evidence-based policymaking, science advice for government. The OECD is having a conference in a month and a half specifically focused on evidence-based policymaking and the decision-making processes that governments use in order to process all of these tremendous changes that are going on around. Science advisory systems are being created in governments around the world. The International Network of Science Advice has been launched within the last 2 years to help prepare scientists and engineers to advise governments on these trends that we're seeing. But this is a relatively new area. This isn't something in a university setting that we train our young scientists and engineers to think about and understand how policies are made, how their knowledge is relevant for policymaking. And I'll return back to that because we need to be rethinking the way in which we prepare the innovation culture around technology development. Key aspects that these capabilities lead towards: adaptive government, adaptive policymaking. The ability, that governments do not have the ability to predict the types of technologies that are coming down the pipeline. What they do have the ability to develop are foresight, horizon scanning, and futures capabilities. And this is another area where the OECD has launched and driven a significant amount of understanding of what types of methods are required to look at these technology trends and think about how to put in place adaptive and adaptable policy frameworks, to think about how they see these trends coming but do not lock themselves into 1900s type technologies that unfortunately will not address the types of societal issues that we've seen. So finally, let me turn to what this means for the role of the university. In a world where government and societal challenges require a more adaptable, more flexible approach to dealing with the impacts of technology on society, We need to have universities that are not just thinking about the skills of the 20-year-olds and 25-year-olds that are going through. I studied quantum physics. I worked in Silicon Valley for 10 years, but now that I'm 10 years out of Silicon Valley, I am out of date on the technologies and the technology trends that are going on there today. If I want to continue to understand the cutting edge, I need to continue to go back to those technology environments and have conversations about what's coming down the pipe and what the implications are for society. Universities need to be rethinking not just what we train the 20 and 25 and 30-year-olds of today, but how we open up the conversation for lifelong learning. Professional and executive education is just the tip of the spear in these types of conversations. We need a significant rethink on the way in which we create an ongoing discussion between societal actors, between the individuals who are going through these education, such that we create a true agora that can have conversations about these challenges. Let me give you just 2 examples from the department that I built at UCL. So I went to UCL 4 years ago to set up this new department, Science, Tech, Engineering, and Public Policy. And at the time, there were only 2 of us. 4 years later, I have over 70 staff in the department. We have 1,200 students a year, and we cannot possibly keep up with the demand that we are facing from governments, from civil society organizations, from the private sector, to train individuals at this interface. Why? Well, 2 examples of programs that we have built. One is our Masters of Public Administration program. Now, this is built to train the next generation of not only civil servants and policymakers, but also scientists and engineers, to come together and work on this interface of how technology is changing society and what that means for the adaptability of government. Now, you cannot do that by sitting in a classroom and lecturing at people like I'm lecturing now. The only way in which you can really have the conversations that are cutting edge and prepare people is to bring together the students in the classroom with the real-world policy challenges. All of our students have to do, for more than 1/3 of their program, a real-world policy project with real-world policy clients. These have ranged from the parts of the World Bank to the OECD to national governments to community and local governments. Now, the idea of bringing into the classroom real-world policymakers with real-world policy problems is about opening up that conversation of how we not only prepare the next generation, but we also leverage the knowledge within the university and leverage the student capability to bring that knowledge to bear on existing policy challenges. This is only one example of the types of new mechanisms we have. A second important example, we run every year a 2-week intensive program modestly entitled How to Change the World. Now, this has 700 young engineers who take part in this 2-week program, where we bring in these real-world policy makers, these real-world challenges, and lay out for the engineering students problems as simple as solve poverty for a rural community in Uganda, or solve energy for a refugee camp. And unsurprisingly, the engineers go, what the heck? I don't understand. But this does 2 things, 2 very important things. The first is it exposes the engineers to an understanding that technology development isn't just about generating the new iPhone. It's not just about generating the technologies that enable market growth and enable the creation of new jobs, but it's also potentially can be harnessed for public interest innovation. That technology development can actually directly impact societal challenges if we harness and motivate it. But that is not a typical part of the undergraduate engineering experience. That's not a typical part of the undergraduate science experience. In fact, it's not the typical part of most engineering career pathways. But that's the type of transition that universities need to be a part of impacting, of creating that type of change in the way young scientists and engineers, as well as existing governments and civil society communities, come together around a university agora, where government policymakers are there, where civil society is there, where the students are there, actively mobilizing their skills to have an impact on these types of technology challenges. I started by talking about the industrial revolutions. In response to the first and second industrial revolution, governments launched a wide range of highly impactful programs for society. ranging from the creation of the modern welfare state, the ideas of retirement as an institution and Social Security, and most importantly, universalized education. In the 1800s, the idea of having to go through an entire career that was provided, educational career that was provided for you by the state, by government, didn't exist. We created these institutions in response to the societal changes that were being brought about by the Industrial Revolution of the time. But I challenge you to think about where equivalent significant policy shifts have been launched or are being developed in response to the Fourth Industrial Revolution. The only one that I hear being discussed significantly is universal basic income. But the big question there, where does that money come from? Where does it come from when, as of today, the 8 richest people in the world now own as much wealth as 50% of the world? How do we find those types of conversations? I don't have answers to these challenges, but what I do have is the suggestion that reforming and transforming the way universities act as a point for this conversation, as a point for students to develop new capabilities and focus their attentions on how to address these societal problems, I think that offers at least one piece of the solution. Thank you very much.
Thank you for that very thought-provoking presentation. As the chair, perhaps I can kick off with a question. As an academic to an academic, might our industry change so much so that actually there's no need for academics?
Short answer is yes. But I think the answer is slightly more complex than that, in the sense that the concept of, I often tell this joke when I sit down with colleagues in academia, there's only 2 institutions in Europe that have not changed significantly in 800 years. The first is the Roman Catholic Church, and the second is academia. They both have the same model that they were operating on roughly 800 years ago. Arguably, the church is now going through adaptation. Now, I tell it as a joke, and most academics in the room go, hang on, hang on, hang on. But we do have an environment where the core mode of academic operation is still focused around research. And it's focused around the model of research where the individual academic goes into the lab and investigates whatever is on their mind that doesn't necessarily connect to society. And one of the big opportunities that is starting to emerge by integrating research and education with real-world societal challenges is a mode where the traditional operation of academia, where you go off and you investigate these ideas on your own, starts to be less relevant compared to the integrated networked knowledge of bringing communities of practice along with communities of thought and scholarship together around problems. So I think you still need academics, but you need a mode of academia and a mode of practice that isn't about isolating individual scholars, but rather bringing together communities of practice. And in those worlds, academics are critical as the knowledge brokers, as the facilitators of that conversation. But that requires a new skill set. It requires an enhancement. It's not just lecturing at, it's talking with. And that's a different mode of operation.
Indeed, I would agree with that, and I see very much the role as the academic becoming much more of the entertainer. It's about entertaining our students to make sure that they can actually get the salient points of our engagement and of our conversation, of our thinking and of our research. So I'd like to open the floor to any questions, colleagues.
There is a saying that if you don't use it, you lose it. I graduated from Indiana University with the 3 disciplines: philosophy, honor program, computer science, hardware and software. And at that time, when I graduated some time ago, some of the people here, maybe they weren't born, 1982. And by the way, I didn't have a scholarship. My name is Najat Bouhlega. One of the things I did, I studied high school by correspondence and then went to the US. I didn't have a scholarship. I worked as a teacher assistant. I taught Arabic as second language and continued to study. And then I went to University of Central Florida and taught computer science. My father had a heart attack, so I had to go back to Saudi Arabia and take good care of my parents. The story here, when you have some people who don't get the chance to go to school, what's going to happen? And also graduates who are not in touch with the latest technology. As you said, you were working with the Silicon Valley, and later on, after 10 years, whatever information you had and mindset, you lost the touch. How in the world we will be able, as you said, universalize education, when in Saudi Arabia, when the lady or the guy, after 5 years of their graduation from high school, they cannot get into university? I would like an answer. I believe that each one of us, old or young, they need to put their hands to really help the community, the global and the local, to be better. Thank you very much.
Thank you. Let me just make two quick responses to that. The first is, I think, I don't want to suggest that you lose education if you don't, once you've had it, it doesn't disappear. You continue to have it. But the point that the main thing that I want to emphasize on that is to stay current, to have an impact in a particular field, you need to continue to have that opportunity to come back and engage with the community that you develop the skills in. The second thing is that one of the things that we frequently lose with our universities is once we graduate, we go away, and if you're anything like me, what you primarily get is a letter saying, great, what are you doing now? And oh, by the way, would you mind doing a bit of a contribution to our alumni fund? Now, that is not the same thing as bringing alumni back into conversations with current students so that you are able to continue to bring that expertise back into the classroom and create those communities of practice. It's not an easy thing to do to shift the mode of education, but it goes to that edutainment, or thinking about how you create an environment where your graduates, those who have gone on and are now your alumni, are the problem holders that come back in and continue to push the edge of your program. I noticed how many colleagues here raised their hands who were from academia. And there is a real opportunity for academia to play a cutting-edge role in making these types of societal transitions.
Yeah, thank you. Can we have the next question, please? Yes, please.
Thank you very much. Yes, I think, in fact, what I can say, my name is Mohsin Hussain, sorry. I work at Griffith University, Australia. Yes, what I can see is you have posed lots of questions. And when you wanted to answer them, and you said that I have no answer, right? So this is the first premise of my question. I have, from my professional background, I have some experience of teaching students the first industrial revolution, second revolution, third revolution, and I was a bit scared about the fourth revolution, what you are trying to say. I'm also an academician. The thing is, what I'm trying to say, that my colleague, Ron, he works on employment, jobs, and jobs. And now, if you think that few million, 5 million truck drivers are going to lose their jobs within 10, 20 years, it was a scary thing. I'm afraid this is going to be a major revolutionary change. Are we prepared for that? That's my question. Thank you.
Short answer is no, we're not prepared. I could speak for hours on where I think the transitions are going to impact us. But I don't think we are having some of the critical conversations that we need to be having about the impacts. John Maynard Keynes in 1928 and 1930 wrote an incredibly interesting paper that I'd encourage you all to go back and read, and it was on the work of my grandchildren. And he was out by a generation or two, but he basically postulated at that point in time something that in the 1950s and 60s was ubiquitous. Eventually, technology will get so good that people don't have to work anymore. In other words, technological evolution will lead to a world in which there is enough productivity that all the basic needs of humanity can be met without human beings needing to work a significant amount. Now, Keynes was probably out by a couple of generations, because Keynes's grandkids right now are coming up on 50s, 60s, and you know, they're approaching retirement at this stage. But his great-great-grandchildren are going to live in a world where AI, machine learning, combined with automation, the Internet of Things, does have the potential to produce a huge amount of the foundational material wealth that we need in order for everyone in society to have a basic level of material happiness, of material foundation. Now, what does that mean in terms of the social structures that we need? We have not, this iPhone gets updated once every 2 years or once every year. And we measure generations of change in terms of the iPhone now in terms of technology. But we're still measuring the rate of change of governance institutions in human lifespans. And as human lifespans are getting longer, that's actually not necessarily helping with the transition of the governance processes as we go along. And we haven't had a firmware update on our brain in about 100,000 years. So these are the types of challenges that add to the type of revolution that is coming. And the question is, how do we begin preparing for it? I do firmly believe that we can make a positive transition, one that does actually begin to spread and share the wealth, but it requires challenging some of our basic premises about how wealth is generated, redistribution of wealth, and how we think about harnessing the economic productivity that's generated from technology for societal impact as opposed to just market impact. And those are some really challenging questions for governments and for businesses to begin to tackle.
Yeah, thank you. Is there any more question? One more questions, and we can leave the rest of the questioning for the break. Please.
Yeah, I have a very short question for you, because you made lots of assumptions about technology and the impact of technology on future development. Number one, development is a very complex kind of process. It's a multidimensional concept that cannot be solved entirely by the technology. And I wanted also to say, why don't you think exactly on the opposite? Which simply means that technology can be also destructive to the society. Yeah. The technology could also have a negative impact. And what I am just thinking about is that when you have 5 million people, those truck drivers, losing their jobs, then they will go after the government. And today in the world we live in, we can see clearly how much protest is going on. And if the government system collapses, the entire technology will collapse, and the society also will collapse with it. So technology could have a positive, but also it could have a negative impact on the society at large. Just like from the World Bank, I had a question, but I will ask her later on. Thank you very much. Yeah.
So I completely agree. And if anyone had the impression that I believe technology solves all problems, then forgive me. Technology does not solve all problems. Technology can create more problems than it solves. But one thing is definitely true. Whether technology is solving problems or creating them, it is coming. The technologies that are already, again, the McKinsey report said it quite effectively. Half of the jobs in the world can be replaced with technologies that exist, have been demonstrated today. Today. That's not even accounting for the new technologies that are coming down the line. Now, development is absolutely a multidimensional issue, and technology doesn't necessarily help with development unless we harness technology's capabilities and harness the inherent innovation capacity towards addressing development and societal issues. Most innovation today goes into these devices that I'm holding up here, that I'm wearing on my wrist. It doesn't necessarily go into addressing the needs of the 50% of the population around the world that cannot afford them. But that goes to the question that Samia raised about institutions, about regulations, about skills. Scientists and engineers who are trained to understand the circuit board. I know a lot about the circuit board inside of here, but until I had graduated my PhD, spent 5 years in Silicon Valley, and then went out and decided I wanted to do something different, I did not understand how these technologies had any impact on anything that Samia talked about. And it took me another 5 years of engagement and development in energy technologies, in climate change, in societal development, to get an understanding of how to use my technical capabilities to impact it. We need to rethink our education structures around science and engineering and policy if we're going to bring those conversations together. Because the way we're doing it right now is not bringing them together.
Thank you. So I think just before I bring this session to an end, I think really that the challenge is down to, in many respects, as I mentioned earlier, universities like Ahlia, UCL, Bradford, and all the other institutions that exist, to really make sure that we design, that we develop interdisciplinary programs that are not singularly focused, where you do bring engineers that can work with business, that can work with entrepreneurs, that can work with lawyers, that can work with medical people, bringing them together to try and bring together innovative program design, integrated curriculum, so that those students are able to deal with the challenges that face themselves, their generations, and of course future generations. So I think really the challenge falls on us as academics to try and make sure we do create students with those attributes that can work in industries that, you know, don't exist yet. So on that positive and uplift point, I'd like to bring this session to an end, and I'm sure you'll join me in congratulating and thanking our keynote speakers. Thank you. This session's now closed.
I would like to thank the panel for answering all the questions and for the audience for asking them. And now I would like to call Professor Abdullah Al-Hawaj, Professor Mansour Al-Ali, and Professor Allam to present a token of appreciation for our keynote speaker, and Dr. Jason Blackstock. If you would like to join a group photo, please come on stage.